Today, we're going to complete the square. Our objective is that we will be able to solve a quadratic equation over the set of complex numbers using an appropriate strategy. So, if we just have an x squared equal to a number, we can solve this by square rooting both sides. And we would get that x equals plus or minus 4, because positive 4 squared is 16, and negative 4 squared is also 16. Here, where we have a binomial squared, we can square root both sides to undo the squared. We'd have x minus 2 equals plus or minus the square root of 5. And then we can just add 2 to both sides, so we'd get that x equals 2 plus or minus the square root of 5. But when we have x squared plus 4x equals negative 5, we can't just square root. Because we have x squared and x. However, if we can find a way to write it as a perfect square trinomial, we could then factor it to be a binomial squared, and then we could use our method of square rooting both sides like we did in the first two examples. So to turn something into a perfect square trinomial, we need to find the magic C value. And that magic C value is going to be b divided by 2 squared. Because then we'll have x squared plus bx plus b over 2 squared, which then factors to b, or x plus b over 2 quantity squared. So here, our b value is 8. So we would have 8 over 2 squared. 8 over 2 is 4. 4 squared is 16, which means this would factor to x plus 4 squared. Here, our b value is negative 7 over 2. That can't be simplified, and the way to square a fraction is square the numerator and square the denominator. So we would add 49 over 4. And then our factor would be x minus 7/2 squared. Ooh. All right, so how can we use perfect square trinomials to solve? We're going to do what's called complete the square. The first thing we need to do is get the x's on one side and the constants on the other. So in our example, we would subtract 4 from both sides so that we just have the x squared and the x equal to a constant. Then, to complete the square, we're going to add b over 2 squared to both sides. In this case, b is negative 8 over 2 squared would be 16. Then we're going to factor the left side and simplify the right side. So x minus b over 2 would be x minus 4 squared equals 37. Then finally, we're going to square root and solve. So we square root to undo the square. We're left with x minus 4 equals plus or minus the square root of 37. And when we add 4 to both sides, we get x equals 4 plus or minus the square root of 37. Now the square root of 37 can't be simplified, but always simplify the radical when possible. Now in this example, our equation just started with x squared. We had an a value of 1. If a does not equal 1, then divide all terms and make sure you divide everything by the a value. The one thing I'll warn you also is you can sort of interchange the dividing by a and the getting the x's on one side and the constants on the other. And if you rearrange first, sometimes that can help you avoid fractions. In this case, everything is divisible by 2, so it doesn't matter. So we'll have x squared minus 6x plus 13 equals 0. We'll get our x's on one side. I'm going to leave space for the term that we're going to add, and then our constant on the other. B over 2 squared would be 9. X squared minus 6x plus 9 would become x minus 3 squared equals negative 4. Square root both sides. We get x minus 3 equals plus or minus 2i. If you're confused about how to go from square root of negative 4 to 2i, go back and review the complex numbers video. And then we'll add 3 to both sides, so we get x equals 3 plus or minus 2i. All right, now on to everyone's favorite situation, fractions. Fractions are not that bad, and we have Desmos. Desmos will help us out. So here we have an a value of 2 again, and everything's divisible by 2, so I'm going to go ahead and divide everything. I'm going to get my x's on one side, leave space for the term I'm going to add. So b over 2 squared. If you're not the greatest with fractions, don't worry. Parentheses, negative 5 over 2, oops, squared. It tells us in decimal form. We don't want decimal form. Click the fraction button on the side. Change it to fraction 4. So we're going to add 25 over 4 to both sides. We know this will factor to x minus 5 halves squared because this is b over 2 and b over 2 is right here. inside the parentheses. If you're not confident in adding an integer and a fraction, again, Desmos is our friend. 2 plus 25 over 4. Again, it's going to give it to us in decimal form. Click the fraction icon on the left. It changes it to a fraction for us. Square root both sides to undo the squared. So we'll have x minus 5 halves equals plus or minus. Now let's see what happens when we pipe that into Desmos. Square root of 33 over 4. It gives us this big long decimal, and it does not give us an option to change it to a fraction because it's an irrational number. The way to square root a fraction, square root the top and square root the bottom. The square root of 33 can't be simplified, so I'm going to leave it as the square root of 33 over the square root of 4 is 2, and then x equals 5 halves plus or minus square root of 33 over 2. You can leave it like that. I would. You could also, because they have the same denominator, also write it, or you might see this depending on what you're working on, 5 plus or minus the square root of 33 all over 2. Either one of these is fine with me. That's all for today. Fill in your summary and I'll see you in class.